Hi guys, happy Monday, chapter 4, day 2. Just want to talk really quickly about what's going to be on Wednesday's quiz. Last week we talked about categorical variables versus quantitative variables. Categorical go in categories, quantitative are counts or measures. And then chapter 3 we talked about relative frequency tables, which one uses percents, relative frequency tables, and then contingency tables, aka two-way tables. And then chapter 4, current chapter, we talked about the types of graphs. We have histograms, we have dot plots, stem and leaf plots, time plots. And then what we're going to spend today talking about is how do you describe a distribution? Okay, it's great that you know the graphs, but can you talk about the center? Any unusual features? Can you talk about the shape? Can you talk about the spread? Okay? So let's jump in. I just want to do some examples with you. First thing I do want to look at is on page 46. Let me turn there. They're talking about histograms, and we're talking about bins. Okay, so let's just make a histogram. Let's just give some data. Let's see. Let's say each of these bins is like 5, 10, 15, 20, 25, 30, 35, let's say 40, okay? So this is a distribution, and we don't know actually what the numbers are, but they could be anything from like 0, 1, 5, 7, 10, 12. It looks like our 10 to 15 bin. Each of these bars is called a bin, okay? This is what we call a bin. 12, 14, 14, 15, dot, 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 dot. Whatever this distribution is. Now, what do we do with this 10 right here? Okay, does this 10, when you count this, does this go into this bin or this bin? Okay, this is what page 46, there's a little, I think, green box. I think it's green. Is it green? You tell me. Basically, it doesn't matter. It's totally up to you. But what does matter is consistency. You have to be consistent where you put that. So if you have a value like 10 that falls right on the edge of a bin, and it can go in this previous bin or the latter bin, you have to decide. Now, if you read the green box, they say that most of the time what we do is we put in the higher bin. So the numbers that are here are actually 10 through 14. And the numbers that would be in this bin would be 15 to 19, and then this bin would be 20 to 24, this would be 25 to 29, etc. You guys get that pattern? 30 to 34, and then this would be 35 to 39. Okay, that's generally what it is. Now it's totally up to you, but for our class, please make note of this, for our class, we will always put the bins we always put a number on the border in the upper bin, okay, rather than the below bin. Okay, so place border values at upper bin. Okay, for our class, just to make it easy, just to make sure we're all on the same page. Technically, if you're gonna make a stats report for something, you know, it doesn't matter, but you have to be consistent. But for our class, let's consistently keep it in the upper bin, okay? All right, let's do some practice problems. Let's take a look at page 65. Let's look at number 6. Okay, go ahead and take a moment to turn there. Make sure you guys pause and pause the video whenever you guys need to, okay? And by the way, sorry about spilling my my cyst the other day. That might have been kind of gross for some of you. I had to throw it away. It was bad. So if you look at number 6, first off, let's identify. Stop moving this around. Is this still centered? What is that? Hopefully all of you say histogram. Yay. So we want to describe the histogram. You know it's a histogram. But when it says describe the distribution of emails, okay? So we're always going to be talking about CUSS here. So let's first look at the center. So the thing about a histogram is we don't know exactly how many values are in each bin, right? Like that first bar you're looking at, where right next to the 1, you can see that one goes to 80. But then look at the third one. The third one's a little ambiguous. Okay, the second one you know goes to 40. But the third one, where does it go to? Is that 17, 18? We're not sure. And frankly, we don't really care what it exactly is. But where would the center of that be? Okay, give me a value. Like a median or mean. Okay, so your mean would be lower than your median here. Median would probably be more appropriate. Now I would say it's somewhere around 2. What do you guys think? Maybe 3. Because look, there's that thing all the way over at 21, or 22 I should say. What is that called? Okay, we'll talk about that in the next section. But the center would be approximately at 2 or 3. So in a test, if you put 2, I'd take it. If you put 3, I'd take it. Now if you said something like 11, I would not take that. Okay, if you said 22, definitely not. All right, well the trick is that if you take that graph, and let's say you were gonna balance it. You took up your pencil, your pen, and you try to find the balance point of that. Where would that be? Would you put your balance point on the 2, the 3, the 4? Where would that be? Probably somewhere around the 2 or the 3, right? Okay. Now, any unusual features? And remember back to our notes last time, unusual features talks about gaps, clusters. We should take a moment to review that right now. Outliers, gaps, and then clusters. Are there any gaps or clusters or outliers here? So there definitely is an outlier, right? There's an outlier at, you would say that's at 22. Okay. And then there's definitely a gap. Now, we will worry, I think next chapter, chapter 5, about how do you calculate an outlier. There's an actual formula that you may have seen before, okay? But right now we're just gonna eyeball it. The next thing, let's talk about shape. Okay, so for shape, we have some options here. Is it unimodal, bimodal, multimodal, symmetric, skewed left or right, is it uniform? This one, I'll give you a hint, has 2 descriptors. Okay, so the first one, you should be able to see that it's skewed. Okay, here's a moment of truth. Is it going to the left or the right? Think about which way the tail is going. It's not where the mode is. It's not where the peak is. It's going to be where the tail is. So the tail is going to the right? So this would be skewed right. And then do you see any modes? I definitely see a mode. So this would be unimodal. So something can be more than one. Like something could be uniform and symmetric. Something could be bimodal and symmetric. Okay? Something cannot be unimodal and bimodal. Think about that. Can something have 1 peak and 2 peaks? No. Okay? And last one is the spread. Okay? So for spread, let's first identify what the minimum value is and what the maximum value here. The minimum, the lowest number of emails, it looks like is it 1? I'm sorry, this outlier should be at 21, right? Because it's counting what's in the next bin. Apologize for that, it's 21. So our minimum here is 1 and our maximum is 21. So spread, you're gonna calculate your range here. Your range is the difference of these two. So don't say your spread is 1 to 21. Rather subtract it. 21 minus 1 is 20. Okay, that's a key difference. Don't say 21 to 1, just say 20. All right, so we have properly described number 6. Let's go to number 12 now on the next page. Get some paper. Okay, so let's read about number 12. So number 12, you can go ahead and pause this right now and read through the problem. It's talking about Wayne Gretzky and his 20 seasons in the NHL. So he's a hockey player. Okay. So it names how many games he played each season. He played 20 seasons, which is a remarkable feat in itself. But what we care about more is we want to put this into a stem and leaf display. Now think about this. Should this be a back-to-back stem and leaf display, or should it just be a regular stem and leaf? It's just being regular because we're not going to be comparing anything. But it's not like we're comparing Wayne Gretzky to another hockey player. Okay, we're not comparing his first 10 years versus his second 10 years. So we're going to have a single stem here. And then let's look at our numbers, and let's decide, what should I make the stem be? What's the minimum here? Look at all those values in your textbook. And it looks like the smallest number is 45. So I'm going to start with a 4 down here. And what's our maximum here? What's our greatest number? If I'm not mistaken, it's 82, right? And there are a lot of numbers in the 80s and the 70s here. So what I'm going to do is I'm going to make this like this. Okay. What I'm going to do is I'm going to split each tens place into 2. So this 4 right here is going to contain numbers between 0 through 4, and then this would be 5 through 8. You'll see this in a second, okay? So our lowest number is 45, and the next one is 48. So anything down here would have been a 40, a 41, a 42, a 43, a 44, okay? Oops, I forgot my key. My key says that 4 with the line 5, that means 45 games. Okay. So anything in the 50s, there is a 54, right, I think. Is there not a 54? Did I just make that up? There's no 54, so I'm gonna skip the 50s. It looks like there's a 60. There's a 64. Now 64, should that go in the bottom 6 or the top 6? It should go right there. So remember, what I'm trying to explain to you is that this would be 40 to 44, and this would be 45 to 49. Okay? 6, nothing else in the 60s. There's a lot in the 70s. In the 70s, it looks like there's a 70, there's a 73, a 74, and a 74. I'm sorry if no, I'm doing this right? If I'm doing this incorrectly, please post it in the comments below. I always wanted to say that. We have an 80, we have a lot of 80s actually. How many 80s do we have? 1, 2, 3, 4, 5, 6. And we have 81, and an 82, and an 82. And I don't think we have anything above that. Right? I think 82 is the maximum. Okay? So here's our stem and leaf plot, or stem and leaf display. So it says describe the shape of this distribution. We can just talk about that. So we want to go cus. Okay? What would you say the center is right here? You can actually calculate the center, right? You can plug this in your calculator and just calculate what the mean or the average is. I already went ahead and done that, and the mean here comes out to 74.35. Now what if we wanted to do the median as well? If there's 20 numbers, where would the median be? It would be between the 10th and the 11th number. So I'm going to start right here and find the 10th and 11th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's somewhere between this, it's 78 and 78. So the median here would be 78. Okay. Any unusual features? Could there be an outlier? Look, most of his seasons were up here, and then there were these 45 and 48. So I would say there's an outlier at 45 and 48. And then there's definitely a gap, right? There's a gap in the 50s right there. What would the shape of this be? So it's hard to see because this is done vertically, but let's pick it horizontally. Let's look at it that way now. Okay, actually, we should look at it the opposite. How can I invert this? Like this? Think about this, because the 40s would be the smallest number. Okay, right? If you were to write this on a number line, if you were to do it like this, like 40, 50, 60, 70, 80, then there would be, I'm gonna do a dot plot right here, 40s, there would be maybe something like right here, there'd be some right here, there'd be, most of the dots would be kind of like this. So this skew goes this way. So this would actually be skewed left. Can you see that? Because the tail is going down to the left. Okay, that's kind of tricky. Let's look at the spread now. We know what our minimum number is. It's 45. Our maximum is 82. So simply 82 minus 45, which is 37. Is that right? 45 is, yeah, 37. Okay. I like the question they ask in part D, right there. So we just combined parts A and B and C right now. Okay, whenever they talk about describe the distribution, this is what we're talking about. But B talked about the shape, so this was this part, and then C wanted to talk about this part, and then now we're talking about D right here. So D says, what are unusual features you see? We have two outliers here. What might explain this? So let's put this into context now. That's why I like this question. Why do you think Wayne Gretzky played such fewer games in these two seasons, 45 and 48, than he did up here? Because usually he's usually in the 70s or the 80s. Injury, a shortened season due to strike, all the ice melted on the ice rink and they had to shorten the season. I don't know. Probably injury though, I would say. Okay? All right. So I'm going to show you how to actually do this on your calculator. Okay? So let's go to page 54. Let me get a new sheet. So page 54. How to create a histogram on your TI calculator. All right. So let's use the data. Let's use data from number 12, the one we just did. Okay. So I'm gonna turn on my calculator. And I'm just going to follow the directions right here. So what you're going to do first, you have to input your data. When you input your data, you go to Stat, and then you hit Edit. Okay, I'm not sure if you guys can see that. So let me say that again. You're going to go to Stat, Edit, and then under L1, you're going to enter data. Okay, so go ahead and pause the video right now and input the data. There should be 20 of them, okay? All right, great, that's done. Now, after you do that, you're going to go to second, y equals. You're trying to go to stat plot, okay? So this is step 1. Step 2, go to stat plot. When you go to stat plot, now you can have multiple plots going at once, okay? There should be 4, at least from our 5 or 3, sorry, 3. So we're just gonna use the first one. So I'm gonna hit enter on the first one, and then you wanna turn it on or off. So if you wanna see it, you wanna make sure you turn it on. Now go down to type, and then, so we chose on, and then for type, let's choose the one that has a histogram. For my calculator, it's the third one in the top row. Okay, so I want you to choose the histogram. You hit enter on that, and your X list, think about where did you put your data? I put my data into L1, I think you did too. And the frequency, we just want to leave it as 1 for right now, okay? So now you're going to hit graph, which is this button right here. So hit graph. So at this point, you may see a histogram, you may not see a histogram. So, sorry, I just kicked it with my good leg. Is that okay now? You might see a histogram, you might not see a histogram. In this case, if you don't see it, what you want to do is you want to hit zoom, and then you want to go to the 9th option, which is zoom stat, and that's going to make it fit in your window. So you go to zoom and you can scroll down to 9, or you can just hit the 9. I'm just going to hit the 9. So now you should be able to see your histogram. Let's see if you can see mine. Does yours kind of look like this? Okay. So you could just trace that. If this is a problem where you had to make a histogram, you could just trace that. Now, if you're asking, like, if I were to draw this, and I don't know, it kind of looks like this, and this, and this, and this, and this-ish, right? My bins are kind of like in the middle of some of these, or my borders are in the middle of some of the bins. So what you do is you go to Window, and then you see where it says X scale. So X scale is, right now their bins are set at 7.4. I don't know, the calculator just thought that was the best number. I don't think so. So let's change our bins to 10. So where it says XSCL, change that to 10, okay? And then go back to your graph. So now your graph, the bins have been changed to 10. Now if you go back in your window, and you can manipulate these numbers however you want, like X minimum, let's put that at 0. Okay, maximum, let's set it a nice round number at 10. Your Y minimum, we can put that at 0. Your X maximum, I don't know, we'll put it like at 20. Y scale, I'll just do it at 1. And then let's see what that looks like. Okay, so this looks a little bit better to me, right? It looks a little bit more like what we did in number 12, where you have most of the data concentrated in the top portion, the 70s and 80s, and you have those outliers, okay? So play around with that, try it out, and let me know if you guys have any questions, okay? Thanks, guys.